trickling in. So welcome, folks. I know some other folks might be trickling in here soon, so we'll get started for time's sake. So welcome to the American Council for Technology Industry Advisory Council Network and Telecommunications Community of Interest. I'm Robert Sears. I'm the government chair of this group, and we're going to get kicked off here. We have a great panel today that is focusing on our recent project underneath the Network and Telecom Community of Interest on the federal use, or not just federal, sorry, the use of non-terrestrial networks in various environments. So we'll jump in here. This is the agenda for today. I'll do some quick NNT overview and some of the projects we're working on, and then hand it over to the panel. So for those who are new, the Network and Telecom Community of Interest is here to provide clear, impartial feedback and recommendations on networks and telecommunication issues identified in collaboration with the government. So really, we're here to help bind industry and government underneath the umbrella of networking and telecommunications, which is the foundation of everything we do, right? You got to have networks, you got to have those communications to make your infrastructures run. This is our leadership here. So myself as the government chair, Richard Zelkowitz, who's the industry chair and is an independent consultant, Stephen Brand from the Department of Energy is our government vice chair, Stephen Mathern from AT&T is an industry vice chair, and we have Deidre Murray from Deidre Murray and Associates, who's a program co-chair, Lee Mosier from Fortinet, program co-chair, and also Ginger Crawford, our communications chair from GDIT. So our NNT does a lot of different activities over the year. We have projects I'll talk about, but we have various what we call programs, and this is one of the programs today. So here's some of the past ones we've done back in August on the Network as a Service, and all of these are recorded, and I believe you can get them off of the NNT ACT-IAC NNT website. We did a overview a couple weeks back on the operational use non-terrestrial network. So this is the second part of a two-series program on this project we've done on the use of non-terrestrial networks. Today is our panel discussion on that particular project, and then in December we have a DHS Spectrum presentation, and also in January an overview of mission DoD 5G. So those are to come. These are the projects, again, operational use of non-terrestrial technology that completed. The folks that are on today were part of that paper on the various use cases, and so we'll be seeing those more in depth. We also have the retirement and replacement for legacy copper networks. That's in progress. There's a next generation network infrastructure task force and our NNT is also part of, and that's in cooperation with the acquisition COI. And we also have two new projects that are starting this year, modernizing federal networks from the campus and beyond. That's looking at actually kind of binding the use of non-terrestrial network technology, last mile technology, and the thing what comes out of retirement and replacement of legacy networks. We're building upon that, and then also the foundations of connecting government and people. That's going to be a really great one, as well as we look at the social and personal impact that networking and telecommunications has on the public. So we're going to jump into our project here. So this was the operational use of non-terrestrial network technology. What we were looking at, examining through various use cases, whether non-terrestrial network transport could be used to address the needs of connectivity in a specific area or project. A lot of the network connectivity is driven by the region, or where a location where services may not be available, and then also, remote areas, different bandwidth needs. So that's what we're going to cover today. We're going to look at the project. There was 5 use cases based on these questionnaires. I won't go into that too much because you'll hear from the folks themselves. But we end up with 5 use case studies, and all of the folks that are that participated are here today to talk more in depth about those particular use cases where they were using one of these types or more of these non-terrestrial technologies, cellular, microwave. We didn't have many on that, private cellular, and of course, low Earth orbiting satellites. So with that, I want to introduce Captain Joe Baczkowski, who's part of my team. He runs our NOAA EndWave engagement and outreach team, and he is here to moderate our panel, and I will let him introduce the panel members, and we'll jump into the meat of this. Thank you.
Great, thanks, Rob. You're exactly at 5 minutes. So I have the clock going, and I'm well known for trying to keep us on time. So in the interest of that, I'm going to change the agenda slightly for the panelists. If you can introduce yourself as you start your case, I think they'll give us a couple extra minutes each. So we are going by, if you've read the white paper, we are going by the case in order. So case number 1 and 2 is actually going to be presented by Richard. And Richard, if you're online, take it away. Also, during the conversation, please raise your hand or put a question in chat. We want this to be a very interactive kind of presentation for y'all. So Richard, it's your turn.
Yeah, good morning. Richard Vogel. I am the lead communications engineer for the National Weather Service ASOS program at this point. And we'll get into the ASOS use study in the second one. This one was going to be presented by another gentleman, but I have quite a bit of experience in the upper air arena and with the low orbiting satellites that they are utilizing. So I said that I would speak to this one as well. Given the high cost and supportability of communications in Alaska, emergence of the LEO satellites as feasible technology for the operational systems, NWS Office of Dissemination in the Alaska region, in cooperation with Department of Energy and EndWave, are testing the Starlink systems in Kodiak, Alaska. Kodiak was chosen for its location, relatively easy access, and the system supported was the Vizsla Autosonde, which is an automated system launcher of weather balloons. Just a little bit about that auto launcher. So that auto launcher is actually located in remote locations where you can actually load, I believe it's 24 balloon launches in a single turntable. And the upper air network is actually comprised of over 100 different upper air set locations, excuse me, that launch twice a day at the same time from every location. So when you think of weather balloons, you know, some people who aren't familiar with those don't really understand the actual impact that a weather balloon can make. But those weather balloons are providing pressure, temperature, and humidity, as well as wind speed based on GPS of how fast the balloon is moving. And all of those are launched, like I said, at the same time twice a day. So you're getting a capture of the entire, each level of the atmosphere as all of those balloons are going up at the same time in all of those different geographical locations. And that is a huge benefit to the models that are generated. So I used to laugh at thinking about weather balloons, but you know, now that I know exactly what they do, it's pretty important stuff that those stations are doing. So next slide, please. That right there is just some pictures of the Starlink installations, and kind of the geographic representation of where they're doing that testing. Okay, we're on to, did we want to ask questions on that, Joe, before we move on to case 2? If anybody had any questions?
Hey, Richard, I was going to ask you a question, and I know the air observation is not your primary area, but what has it been a challenge at these locations for the comms? I mean, I think what's traditionally used? Is it copper? Yeah. Is it, you know, like dial-up? Is it?
Yeah, it definitely was dial-up modems for a long time, until, you know, just recently I think they have started moving over to more of an IP infrastructure. But the problem, especially in Alaska region, and it's affecting us in ASOS as well as upper air, is that there are many locations in Alaska where you can't get cellular and you can't get hardline Ethernet or broadband services, and so satellite is your only option. For the upper air, I know that there were pictures of the Starlink antennas. I know that they're also looking at the ones that we're utilizing in ASOS, which is the through the AT&T EIS contract through OneWeb, which is more of a heated dual parabolic antennas. So yes, it especially in Alaska, it's extremely hard to find good communications. So satellite is kind of one of your only paths, except for a few locations.
Makes sense. Thank you.
Mhm.
I have a follow-up question also, if I may. Could you describe a little bit about how the satellite and the cellular came together? I haven't been able to dig into the details yet, but I'm very intrigued by the approach towards using the two of those complementary technologies.
Well, what we typically do, and I'm speaking to that use case, but I wasn't involved in the rollout of any of that testing for the upper air network. But what we have done, or how we determine what's going to be the best mechanism, whether it's 4G, whether it's satellite, is we actually partner with AT&T to do a site survey at all of our locations. So they will go in, take a look at the layout of where the equipment is located, do cellular surveys to see whether the 4G, 5G service is not just available, but is it adequate for the data that we're going to be sending? And if it's not, then they will turn that over to the cellular team to come in and actually do a full satellite site survey so that we can look at how those antennas need to be mounted, what's the best location for angle of line of sight to the satellite itself. And then we will then work with, and then we work through AT&T and the satellite providers to actually then conduct the installation. And then once the installation for those transport services are done, then we come in after that and hook up the actual communication, the actual routers that communicate with the systems themselves.
Great. And is that cellular review for public cellular, or like commercial cellular, or private cellular that putting up on-go type of antennas and technologies?
For the current project that I'm involved in, we're doing primarily FirstNet cellular. So we're not doing any kind of MPLS circuit or anything like that. We are utilizing public internet, but we are using a FirstNet channel. So I think you have the option. If the option is you want to come in and set up a private cellular network, then you can absolutely do that. It just depends on what your requirements are and how you're trying to architect that network.
Great. Thank you.
You're welcome. Okay, if there's no further questions, I'll move on to case study 2. So this is the one that I'm primarily involved in. So National Weather Service, ASOS, which is our automated surface observing system. And those are all of our weather sensing systems that are at all of your medium and large scale airports around the CONUS and OCONUS, as well as Department of Defense, Navy, air stations globally. So everything that is on the flight line, providing safety of flight, as well as we have some standalone stations that are doing not necessarily aviation operations, but provide more climatic based data. So we're going through a service life extension program in ASOS, and we're labeling that ASOS 2.0. Our current legacy infrastructure for the ASOS today is all 1980s analog dial-up modems and POTS lines. So as you can imagine, it's riddled with obsolescence, and all of the telecommunication companies are trying to get us off of copper. So in order to get to our ASOS 2.0 state with all IP infrastructure, we are systematically rolling through what we're calling, even though it's not on here, we're calling it the ASOS 1.5 communications infrastructure, where we are actually removing the POTS lines and putting IP in on our old systems that still expect to see a modem. So we're having to utilize things like serial servers that have virtual modem interfaces to trick the system into thinking it's still connected to a modem, even though it isn't. And then we're able to transport those traditionally, transferred over POTS lines, we're now able to send that information over IP, and most of that is happening over 4G, 5G, and satellite. We do have a limited number of stations that we will have to do hardline connections, but for the most part, it's cellular and the OneWeb satellite service. Next slide. And then that's kind of that is a picture of what you would typically see on a flight line. So the tall red and white pole has a wind sensor up on top of it, and then you have sensors that are handling present weather and visibility, freezing rain, temperature, humidity, dew point, cloud height, rain accumulate, or precipitation accumulation, lightning sensors. So all of that data is collected from each one of those sensors and sent to a central processing cabinet on airport property. And then that's where the transmission of, once all the algorithms and everything are run, that's where we send out our observations from ASOS, which our primary one is called a METAR. If you've ever heard of a METAR, that's where most of your METARs are coming from in the US airports, is from that system right there.
And this provides weather to the pilots, right?
Yes.
Yeah. So
correct.
Pretty important for landing, taking off, and flying in general.
Yes. Yeah. There's a lot of locations where if these systems go down, they have to divert. Airline traffic. They will not land, especially if it's a unmanned tower. If the ASOS is down, you cannot land the airplane.
So you're why my flights are late. I was kidding.
Yes, could be.
Or bumpy, right? Or turbulent.
Yeah.
Well, we don't cause the turbulence, but yeah.
Got to monitor it. Well, this is great. And the
Yeah.
emulation you were talking about, that's really awesome, because that is very pertinent to the retirement of copper networks that we're talking about, because there's things that you have to do. You can't, a lot of stuff just can't transfer over to IP or MPLS or Ethernet really quick. So that's great to hear about how you're tricking the serial kind of interface to run over IP network.
Yeah, and for most of your serial type connections, a standard serial server works just fine to kind of take those serial lines and move them over to IP. But when you're dealing with a system that was built in the 80s and there really is no Windows or Linux OS, it's kind of all firmware based, and the developers are long gone, and you're just stuck with what you have. There are certain modes in our system that will not work unless it thinks you've connected via a modem. So trying to find a way to trick a system to think it's still talking to a modem when it's talking to a serial to Ethernet translator was quite the challenge. So there was quite a bit of effort that we put in to kind of get that up and running.
Awesome. Very good. Thanks.
Yeah, you're welcome.
Any other questions out there? If you think of any other questions, even later after this presentation, so feel free to contact us and we'll try to get to the presenters. So thank you very much, Richard. All right, next is Don. Are you online, Don?
I am.
Okay,
Good morning, everyone. I am Don Jones. I actually work for NOAA's Office of Marine and Aviation Operations. I am the lead for emerging technologies for the Marine Operations Engineering Group. NOAA has the largest fleet of federal oceanographic research and survey ships. And so we operate mostly within the EEZ, but we do have ships that have global missions. And so we potentially could operate anywhere in the globe to collect our data. We have partners who, whether they're federal science centers or whether they're academic or even commercial scientists that need to collect data at various regions around the world, they'll charter our ships and we'll take them wherever they need to go and collect their data. And in addition to that, there's a lot more interest in operating in the polar regions. And so in 2020, these requirements and also the interest of the science parties to be able to have shoreside collaborators being able to dial in either to control a mission sensor on a ship or to help with the research and the data analysis that's going on the ships, allowing those remote folks to have access to the ships when they're not actually on board the ships. So all of those requirements were driving us to look at our communications infrastructure and work on changing them. The ships were originally installed with legacy GEO satellite receiver systems, the traditional VSAT system. We were seeing latencies in the 1.2 to sometimes up to 2 to 2.2 second latencies. And so with all of these, our business processes moving more web-centric, and with all the requirements for people wanting access to the ship, those latencies were just not allowing reliable communications between the ship and those who needed to access the data or getting the data off the ship. And so in 2020, LEO, the low Earth orbiting systems, were starting to kind of come around. And so we started looking into that, and Starlink was the only one that was mature enough, that had full global coverage, as well as allowed mobile connections for our ships that were underway operating at sea. And there are other systems that are coming online now, but we at the time decided that we were going to go with Starlink, and so that's what we did. And working with NWAVE and the OMAO Marine and Aviation Cyber Center, we made sure that those connections met all of the federal requirements. So we're TICAP compliant. We have protected data links between the ships and the trusted campus. And so it's been a really, really good effort and evolution. And if you can go to the next slide, please. So these are some of the pictures of the Starlink installation on some of our ships. We do have Starlink on all 15 of our ships now. We have a few ships with dual Starlink terminals. So the upper left picture that you see there is NOAA ship Ruben Lasker. And you can see just to the right of the fleet broadband antenna, the sailor antenna, two little nubs that are sticking up above the canvas there. Those are the two Starlink antenna systems on the ship. So what this has allowed us to do is we now have, with the legacy GEO, we had to, it was really expensive, and we were only able to get maybe 5 to 6 megabit connection speeds, and that's combined uplink and downlink. So maybe 1.2 megabit uplink, 3.5 to 4 megabit downlink. But with Starlink, we're able to see much higher connection speeds. Our subscription services are we're buying a data bucket. So those are some of the constraints that we have to work under is make sure that we're not saturating the bandwidth and then eating all of our data bucket up in the first 3 or 4 days of a month. But it's allowing us to have extremely reliable, very consistent data connections, and we can have multiple connections, either offshore for remote scientists coming in, or actually having data streams coming off the ship using this technology. And the connections are reliable enough that there are very, very few packet losses. We're not having to retransmit the same thing over and over again. So it really has enabled us to make the data that we collect available to those stakeholders onshore that need it, but allowing outside people to remote into the ship and help the scientists that are actually on board. So huge success in our eyes. We just signed a 5-year IDIQ for the Starlink services to continue into the future, and so we're really excited to continue leveraging this technology for our requirements. And one of those new requirements is the picture on the bottom there is that is a DRIX uncrewed surface vehicle. So it's a vehicle that's manufactured in France. And the reason we chose this particular vehicle is because it's the only technology that can match ship speed. So we can use this vehicle to co-survey with a ship and actually keep up with the ship so that the ship is not having to stop and wait for the vehicle to catch up or anything like that. So these vehicles were originally delivered with an Iridium satellite system on board. And once Starlink became viable and commercially available, we transitioned the connection on these platforms to Starlink as well. And amazing change. These vehicles come with full situational awareness sensors so that we can actually operate them remotely. They can be hundreds of miles away potentially, and we have somebody sitting in an office driving these things around to collect the data that we're out there collecting. And full situational awareness. We have 10 camera feeds, radar feed, the sensor, the acoustic sensors that are on the platform. We're able to establish remote desktop sessions and monitor and manage the data that's being collected. You tweak the performance parameters of the sonar systems, and so just amazing capabilities with Starlink on these things now. And so with more and more uncrewed technologies becoming available, it just makes a lot of sense for us to continue with Starlink on that. And just a plug for our Aviation Operations Center. I talked to the lead engineer over there, and they're actually starting to look at Starlink on the bigger aircraft. So the Hurricane Hunters and the high altitude atmospheric flight missions that are conducted there. So there's going to be like 4 aircraft that potentially could have Starlink on those aircraft as well. So just amazing technology. So we were very happy with how it's been performed.
Hey, Don. So
yes,
really quick, were you still, I know when you first transitioned over, you had significant savings, but do you continue to realize that? Or because now you use more data, that gap is quickly closing?
It's still a pretty significant savings. So with our legacy GEO VSAT services, we were paying roughly $4 to $4.5 million a year for the fleet. We first started Starlink at half that, a little bit less than half that. So 1.8 million for the 15 ships for the first year. We've learned a little bit since then. I think our actual costs are going to be closer to maybe $2.5 million a year for the fleet with Starlink instead of 3.5 to 4 that we were doing with VSAT. So it's still realizing a cost savings over what traditional VSAT or legacy VSAT services were, but it's not half like we thought it was going to be.
Wow, very cool.
Hey, Don, question for you. Architecturally, obviously, I see the LEO essentially like the wide area network connection and your core connectivity. How do you handle the interconnected connections for all of the devices and the sensors and the local networking, and as well as the remote, like, extending out from the ship? Is that Wi-Fi? Is that also all using the same LEO connection, or how do you handle that interconnection of all the device components?
Yeah, that's a great question. So I don't know if you all are familiar with, but Starlink comes with a Wi-Fi router that comes as part of the kit. We do not use the Wi-Fi router because the Wi-Fi router delivers traffic directly to commercial internet. And so to meet the FSMA requirements, what we do is we take and connect the Starlink modem into a firewall appliance on the ship. And so the rest of the ship's infrastructure then connects to that WAN connection through that firewall appliance. And that's also what allows us to encrypt that traffic between the ship and the trusted campus. So it's a fully encrypted, protected channel that all of our data from the ship gets delivered into the trusted campus. So,
and does that, from a performance standpoint, give you the ideal performance, or is that just better than what you had, so it's good enough? I mean, have you looked at alternatives such as, again, using private cellular, where you can use 5G for some of that interconnection?
Right, and that's another great question. So we have multiple WAN systems that we provision on the ship, and so it just depends on. So we do have 4G, 5G modems on the ship as well, and so we can actually connect to an MPLS cloud when the ships are close to shore and they actually have a reliable cellular service. We still have not fleshed out the full integrated meshing of all of those WAN technologies. It's something that we're still working through so that we can meet all the cyber and federal requirements for our outbound and inbound connections. But no, it's to go back to your question, the overhead infrastructure to meet the cyber and TICAP federal requirements and those things, that does come with overhead.
Right.
The published Starlink performance metrics, we do not realize that because of this overhead. It hasn't impacted us yet. We're still able to establish and maintain connections with the bandwidth and the data caps that allow us to do what we need to do. I'm sure our requirements are going to grow, and we're going to have to work with NWAVE and our IT folks to see if we can streamline and reduce that overhead as much as possible. But there is a hit, yes.
Yeah. Has there ever been a discussion of that alternative of using a private 5G to accomplish the LAN objectives so that you can get some of the benefits of the security without having to tap into the public network?
We have talked about cellular. It is a topic of discussion, but no, we have not fully investigated those capabilities, and so no, we're not to that point yet.
Okay, sorry I have to cut it off. We have we're running. So thank you very much, Don. And
absolutely,
we will move on to Andrew.
Good morning, everyone. Thanks very much for having me. I'm Andrew Wiedlea. I'm with the Energy Science Network, or ESnet's science engagement team. We're housed at Lawrence Berkeley National Laboratory, but we support all of the Office of Science user facilities and lab sites around the country. And then we also manage circuits directly to the high energy physics community, primarily in CERN, as well as peering with a couple hundred other research and educational networks, including NWAVE, who we partner with on all kinds of things. So I'm going to talk a little bit about efforts we have underway under a project called the Greenfield Wireless Edge. Really what this is about is an effort to expand capabilities to support Office of Science research activities that are happening sort of outside of the framework of lab sites or user facilities. Oftentimes these are sensor fields in, say, the Rocky Mountains or in deserts or wherever. And so we're using a variety of different wireless and satellite capabilities to support those activities as we kind of figure out what our market position and what our product position in this space is going to be for future versions of ESnet. Next slide, please. I think, Joe, do you have some of the slides I showed over before, or are those after these?
They should have been included.
They're after.
Okay, so let's keep going. Let me skip this slide then. Perfect. And let's go to the next slide. So yeah, that's great. So that's, sorry, next slide. There we go. So that's a little on what we're trying to do. I mean, really what we're trying to do, this is, we're in the process of developing sort of our product, our service line support for wireless field science, particularly for earth and environmental sciences, but also increasingly we're engaging with folks like the DOE's Office of Electricity, who are doing a variety of interesting projects on geothermal and wind and other applications that need to be supported through wireless and satellite means. And then as well as figuring out, this market is rapidly developing. We're all using Starlink now, but Kuiper and AWS's version of this is coming down the pike. The European Union is launching low Earth satellite constellations. I guess I saw some estimate that there's going to be about 50,000 low Earth orbit satellites on orbit in the next decade by one estimate. So there's going to be a lot of communication options, including things like cellular directly to low Earth orbit satellite systems. So we're very interested in what that means for us and how we integrate that into the ESnet fiber network. Next slide, please. So we're developing sort of a pattern language or a common way of doing things. Increasingly, our support for DOE field sciences is kind of devolving into this sort of pattern, where what you have is you have sensor fields that have many different sensors that may be used by a variety of different variety of different kinds of systems studying things like hydrology, plant life, flora, fauna, energy use, weather, micro measurements of all different kinds. You're increasingly getting into things like, down the road with genetics and other kinds of sampling methods. And so those are scattered across an area. And so what we're looking to do is use a variety of mechanisms to support kind of last mile communications. We're not using satellite for that really because the overhead in power, oftentimes you're operating in places that electrical power doesn't exist or commercial cellular doesn't exist. So in those cases, we're exploring how we deploy CBRS or private 4G or 5G systems to support kind of the last mile spread of data services to a geographic area. We're also using things like LoRa and other mesh network capabilities to do that, as well as directional Wi-Fi. But at some point, somewhere in the back, you have a place where you can have an accumulation point where multiple LAN capabilities, and maybe multiple cell sites, and maybe multiple LoRa systems that are running, and maybe both operating together like we're doing in Colorado. You have an accumulation point. Typically, that's a point that also has either a decent amount of solar power or a decent amount of LAN of power. And those are then, we're using satellite or commercial cellular primarily, or both, to backhaul data as data needs from these sensor sites sort of grows. So we are primarily using Starlink for that backhaul from private cellular systems that are deployed forward back to ESnet's core. Next slide.
Andrew, real quick, the balancing accumulator, what is that technology?
So we're working on that. I mean, it can be anything from we're just using like standard load balancing with a router to we've been exploring Peptide there's a company called Peptide that has a load bonding capability to create a virtual circuit out of multiple WAN technologies at the same time. And so we're beginning some explorations this winter to see how that performs in a multi-Starlink, multi-cellular environment.
Nice.
So right now we've been primarily operating using kind of as a laboratory a science field out in the Colorado Rockies called the Watershed Function Science Focus Area, which just sort of traipses right off the tongue. But it's an effort by a number of different national laboratories to basically put hundreds of instruments all throughout a remote area near Mount Crested Butte, Colorado, to measure sort of everything from sort of sub high atmosphere to sub bedrock. And then integrate that into to physics multi-phenomenology models. So we have, as part of that, we have a CBRS, a private 5G standalone system operating on the side of a mountain at about 3,300 meters. And we built that to explore what does it mean to like build our own kind of cell tower and what kind of costs are involved with that, and how do we operate it remotely. And that's been running now for about a year. We're about to go through a process of repositioning where it points and where it's shooting. But right now we're using that to support a very tight directional beam to a sensor field on a mountain nearby that's a couple miles away. And that supports a solar powered accumulation site, which is then providing LoRa and Wi-Fi to local area sensors.
Andrew, we have a question on the chat.
Yeah, shoot.
This is from Chris Peabody. What has your experience been with LoRa WAN technologies? It would seem to be ideal for low bandwidth sensor type.
Yeah. LoRa is really cool. I mean, you can operate like, sense systems off like watch batteries for long periods of time. So if you have a low bandwidth system that needs to chirp in, say, once a day or once a week, LoRa works really well for that. We've been using that in aspen forests to spread it. Obviously, the lower lower frequencies work better than the cellular frequencies in getting into that space. And the sensors that are deployed out there are very low bandwidth. So yeah, that works really well. And the cool thing about LoRa is there's starting to become more and more sort of commercial options available. And there's some concepts, like I think Druid has a concept where you can combine your private cellular and LoRa into sort of one managed network with central authentication. So there's a lot of interesting things that are happening with LoRa. Let me know if that got at the question.
Yep, that looks good.
Yeah, I mean, there's a lot of things where like cellular's great for some things, and LoRa is better for other things, and you kind of want to use whatever technology works best.
Can I ask a follow-up question, Andrew?
Yeah, please.
Yeah, on the what is your practical lessons learned and experience? You mentioned just now cellular is good for some things, not others.
Yeah.
How is the private cellular played out? Because there's a lot of people interested in that for similar use cases like water utilities, and so many people have the same challenge. How does it actually work for you in real life?
Yeah, so experience with the technology is still a bit fiddly. It's definitely not as easy as Wi-Fi to deploy out in the field, but we're in the process of expanding from a couple of sites now. We're also doing some in-building work at Lawrence Berkeley National Lab with private cellular, but we're trying to expand to 5 or 10 sites by the end of this year. Yeah, Peplink, that was the technology. But in terms of experience, it can work really, really well. It's really cool when you have it up and going. Sort of getting things set up and going is still takes a bit of experience, and for some applications it works well, particularly out in Colorado, where you can throw out a CBRS system and basically you have all the bandwidth you need because there's nobody else out there.
Right.
When you deploy it in the Bay Area, you do find you have more restricted channel allocations, but the technology is very much evolving. And there's, our hope is that there's going to be more spectrum put into dynamic spectrum management capabilities as things progress. So I'm really excited about it. It fits a valuable niche. Let me know if that answered your question.
That's great. Thank you.
Yeah, and I'd love to talk to you more about that. I mean, happy to share our experience. A part of what we want to do is, as we're doing these things, we want to document what we're learning from this and how it works. We're definitely finding that 5G SA is kind of leaning forward maybe a little too far from the market because it's hard to find end user devices that are affordable that'll work on that reliably. But 4G seems to be very, very easy to set up, relatively more easier to set up, and with things like the new Qualcomm RedCap radios coming out, you get the price point down to get devices onto those systems to about $30. So that's really exciting.
Okay, if we can move on.
Yeah, sorry. Anyway, so we're expanding this next year, looking to go to more sites, and obviously forum like this are really important because we want to find new use and applications. And very, very interested in swapping notes with some of the other panelists about how they deployed systems on water as we look at wind farms and things that are happening offshore. So with that, I'll conclude. Thanks very much.
Thank you, Andrew. And next we have Kevin and Sharon.
Good morning. My name is Kevin Hamer, and I'm with the Yukon-Kuskokwim Delta Travel Broadband Consortium.
Waka Goyana Diluchi. My name is Sharon Hamer. I'm with a tribal-owned for-profit company, ACT-IAC Holdings, and then also co-founder to the tribal nonprofit Kevin just mentioned, the YKD Tribal Broadband Consortium. Thank you and welcome to this presentation.
Our case study is actually a tribal government-based use case out in remote areas of Alaska and the Yukon-Kuskokwim Delta area, which is western Alaska along the west coast of the Bering Sea and up the 2 largest rivers in Alaska, the Kuskokwim River and the Yukon River. Where they enter the Bering Sea is called the Yukon-Kuskokwim Delta. It's an area about the size of the state of Washington, and there are 56 tribal communities in that area. You'll go to the next slide, please. Thank you. So that's a picture that we'll come back to. It's actually the tower we built in our tribal community of ACT-IAC, Alaska. That was in 2021. Next slide, please. So we wanted in our area of Alaska, in the Yukon-Kuskokwim Delta, there was no fiber landing stations, there's no cable, there's no broadband internet in 2020, 2021. When LEO was first starting to operate or become available in the polar areas where we are in Alaska, specifically in 2021. So we had an opportunity as a tribal community to try and get our ACT-IAC Native community, which is one of the 229 federally recognized tribes in Alaska, in that remote area of the YKD, try and get them a broadband solution, and the first broadband solution in remote Southwest Alaska. And this is all run by our tribal community and our tribal business, and what we've created a nonprofit made up of tribal governments, the YKD Tribal Broadband Consortium. Next slide, please. So setting the stage, extreme conditions in remote Alaska. 56 tribes in our YK Delta. As I said, larger than the state of Washington. And each of our tribal communities is an infrastructure island. There is no power, there are no roads, no water sewer system. Whatever you can do within that tribal community is the extent of your infrastructure. So there aren't any power lines running from community to community or back to a network. What they had is a terrestrial microwave network called the Terra Network, which is a series of microwave towers out to our communities in the YK Delta from the Anchorage area. And that is old microwave technology. The best you could get up until 2021, when we were doing this project, was 10 megabits per second download speed and 2 megabits per second upload speed. And if you got that, you were lucky. And if you got that, you paid $315 a month with very stringent data caps. So needless to say, there was no broadband, and whatever service you could get, both cellular and internet, was very, very poor quality and not affordable. So we're trying to figure out how to get this done. And in 2021, we embarked upon a project for our tribal community in ACT-IAC. And as we're doing this project, as you know, we were successful. It can be done. Next slide, please. So in June of 2021, we started the ACT-IAC LEO project. And that was to use OneWeb as the low Earth orbit satellite service provider. OneWeb is a parabolic antenna. We built, as you saw that first picture, we built a tower in our community, not to get access to the satellite, the LEO satellites, but for our transponders. We used a 2.5 gigahertz spectrum license for the tribe that we got through the FCC's Rural Travel Priority Window to do fixed wireless to the home, and brought in our 75 by 15 beam OneWeb satellite, and then put subscriber modules in all of our homes in the ACT-IAC Native community, and turned that on in November 15th of 2021 to become the first broadband available to the public in the YK Delta, using, again, low Earth orbit satellite. Again, that was built, the project was run by all Indigenous people. So that's in remote communities, Indigenous people find a way. That's something you'll see in Bush, Alaska. So next slide, please. Moving on from what we did with OneWeb. OneWeb was our first. We had that up and running in 2021, 2022. The problem with OneWeb for our remote travel communities is it's expensive. It's about at the time, $25,000 a month for us to provide satellite service through OneWeb to approximately 120 homes throughout our community. And that's just not on a per capita basis affordable. We used some grant funding to pay for that first year. And then, fortunately, Starlink in 2022, in November of 2022, started offering service, LEO service, in the Alaska area. So 2021, OneWeb was the only service provider, LEO service provider, that was available. 2022, Starlink started offering service. So we got some grant funds under NTIA and started a nonprofit from our own tribal business in ACT-IAC. We created the YK Delta Travel Broadband Consortium, and we applied for grant funding to provide broadband service, LEO broadband service to our tribal communities in the YK Delta. You can see that area of the YK Delta in Alaska. You see where it is in that lower right caption, and you see the 56 tribes that are contained within that area called the YK Delta, mostly along the lower southern Kuskokwim River and northern along the Yukon River. So you can see that none of those had broadband service. We now got grant funding in September, finally, after 3 years of trying to get it, to provide low Earth orbit broadband to 9 of our 56 tribal communities in the YK Delta. Those are the 9 you see. We have actually started putting Starlink units in all of our homes and the tribal office within those 9 tribal communities. They'll be completely covered by affordable broadband using Starlink. We have, to this date, we're doing another one this week out in you'll see that along the Yukon River in the north, Mountain Village, which is a Skarmute along the Yukon River. That's Karsmute. And that's where our team is working this week to provide Starlink units to every home and the tribal office. It's a little downriver from St. Mary's Pilot Station. So those we've completed 4 or 5 tribes, 5 tribal villages where we have broadband, Starlink LEO broadband for all of the homes and the tribal offices. We'll finish up the additional 4 tribes, hopefully before it gets too cold and for us to continue work in the late December, January timeframe. And that's one of the challenges in remote Alaska. Doing any kind of work is seasonal and very challenging in the winter months to get any equipment, transport, and actually get outdoor work done. So next slide, please. We're doing this, Leo, because as you've heard from the other presentations, in remote areas.
Hey, Kevin, sorry, we had a question in chat.
Oh, certainly, yeah.
You probably heard this 100 times. So how has the Starlink flat panel dish fared in the snow and ice?
Yeah, it's fared fairly well. So you've got the flat panel, which again is just a horizontal. There are a number of different panels that are operating. We've got the generation 2 and the generation 3 now of the panels themselves, the outdoor panels. The generation 2, the residential unit, came with a heater, which you could actually turn on or use automatic. That heater, if you put it on auto or put it on for the panel itself, had a tendency to burn up the ends, the connected ends within the panel itself. So the newest version, the generation 3 version of the panel, is actually a little bit wider, and it does not come with that internal heater. It's not needed. Our location in Bethel, where we live, we've never turned it on. It's never been needed to be turned on. So it works very well. The generation 3 is better than the generation 2 for that reason alone. So we haven't had an issue with the down to -60 in our area. Moving along here, again, the use case for LEO is, as you know, there's no fiber optic. Where there's no fiber optic infrastructure, there's no other commercial-based terrestrial networks that are available to these communities. There is grant funding available, and a lot of those funds will be used to create a fiber to infrastructure to some of these remote areas. But that takes a long time. With that, years across hundreds of miles of frozen tundra, and many wildlife refuges and federal lands in between, landing stations and new interconnections to a fiber cable backbone. LEO is really the only option for our remote communities in the near future. And once you have an affordable solution like Starlink, you have a choice now. When fiber comes along, you can choose to keep your Starlink unit or move to the fiber network, depending on what the price is. And we hope prices in remote areas are going to be the same for our residential customers in urban areas. So, the next slide, please. Is that ours? No, I think we're pretty much, if I could move back to that first slide, if you don't, I'd like to leave on that first slide. So this is an actual picture. This is our crews from ACT-IAC. That's our telco shelter on the left with parabolic OneWeb antenna that we put in place in 2021. And that to the right is us putting up a subscriber module at home. Cambium network we used at the time, and then to the right is the original and still existing tower structure for our 3 transponders at the top. We put that in our native community of ACT-IAC, and you know, this is again this all done by indigenous people, led by indigenous people in remote areas of Alaska. So we're very proud of that, and we look forward to finishing up our remaining 4 tribal communities. So all of our people will be on the right side of the digital divide finally. Any questions for Sharon or I?
Looks great. Thank you, Kevin and Sharon.
All right. Well, Joe, I could close it out. We're
Okay.
getting close to the end here. So definitely, please, folks, go check out the link on the report. But also, you know, there was a lot of interaction today. Kirk, we got your message. Chris, you know, for those who want to participate in our projects, please reach out, because what Kevin and Sharon just talked about, I think hits home for our foundation of connecting government and people. And it's not just federal government, you got tribal government here, and these projects that are these challenging projects where you're looking at government funding, funding from NTIA or other projects, USDA Connect, and really trying to tackle a need. And you know, Kevin and Sharon, your need is so extreme in the regions you're at, and it tells a great story of, you know, going after getting the funding, getting the relationships, and tangibly building something that really enables your community in an area that you know, is definitely underserved. So again, thanks for sharing that, and please, folks, participate in our projects. And with that, I will close it out. Thank you for joining us, and you know, please keep looking at our upcoming programs and projects. Thank you very much. Thanks, panel.